A professional video camera is a high-end device for creating electronic moving images. Originally developed for use in television studios, they are now also used for music videos, direct-to-video movies, corporate and educational videos, marriage videos etc. Since the 2010s, most of the professional video cameras are digital professional video cameras. With the advent of digital video capture in the 2000s, the distinction between professional video cameras and movie cameras disappeared as the intermittent mechanism became the same. Nowadays, mid-range cameras exclusively used for television and other works are termed as professional video cameras. History: earliest video cameras were mechanical flying spot scanners which were in use in the 1920s and 1930s during the period of mechanical television. Improvements in video camera tubes in the 1930s ushered in the era of electronic television. Earlier, cameras were very large devices, almost always in two sections. The camera section held the lens and tube preamps and other necessary electronics, and was connected with a large diameter multi-core cable to the rest of the camera electronics, usually mounted in a rack. The rack would be in a separate room in the studio, or in a remote truck. The camera head could not generate a video picture signal on its own. The video signal was output from the rack unit to the rest of the studio for switching and transmission. By the 50s, electronic miniaturization had progressed to the point where some monochrome cameras could operate stand-alone and even be handheld. But the studio configuration remained, with the large cable bundle transmitting the signals back to the CCU. The CCU in turn was used to align and operate the camera's functions, such as exposure, system timing, and video and black levels. The first color cameras, notably the Rca Tk 4041st series, were much more complex with their 3 pickup tubes, and the size and weight drastically increased. Handheld color cameras did not come into general use until the early 1970s. The first generation of cameras was split into a camera head unit connected via a cable bundle to a backpack CCU. The Ikegami Hill 33, the Rca Tk 45 and the Thompson Microcam were portable 2-piece color cameras introduced in the early 1970s. For field work a separate VTR was still required to record the camera's video output. Typically this was either a portable 1-inch reel-to-reel VTR, or a portable 3/4 U-matic VCR. Typically, the 2 camera units would be carried by the camera operator, while a tape operator would carry the portable recorder. With the introduction of the Rca Tk 76 in 1976, camera operators were finally able to carry on their shoulders a 1-piece camera containing all the electronics to output a broadcast-quality composite video signal. A separate videotape recording unit was still required. Electronic news-gathering cameras rapidly replaced the 16mm film cameras for TV news production around 1940s because the cost of shooting on film was significantly more than shooting on a reusable tape. Portable videotape production also enabled much faster turnaround time for the quick completion of news stories, compared to the need to chemically process film before it could be shown or edited. However, some news feature stories for weekly news magazine shows continued to use 16mm film cameras until the 1990s. At first all these cameras used tube-based sensors, but CCD images came on the scene in the mid-80s, bringing numerous benefits. Early CCD cameras could not match the color or resolution of their tube counterparts, but the benefits of CCD technology, such as introducing smaller and lightweight cameras, a better and more stable image and no need for calibration meant development on CCD images quickly took off and, once rivaling and offering a superior image to a tube sensor, began displacing tube-based cameras, the latter of which were all but disused by the early 1990s. Eventually, cameras with the recorder permanently mated to the camera head became the norm for ENG. In studio cameras, the camera electronics shrank, and CCD images replaced the pickup tubes. The thick multi-core cables connecting the camera head to the CCU were replaced in the late 70s with triax connections, a slender video cable that carried multiple video signals, intercom audio, and control circuits, and could be run for a mile or more. As the camera innards shrunk, the electronics no longer dictated the size of the enclosure, However, the box shape remained, as it is necessary to hold the large studio lenses, teleprompters, electronic viewfinder, and other paraphernalia needed for studio and sports production. Electronic field production cameras were often mounted in studio configurations inside a mounting cage. This cage supported the additional studio accessories. In the late 1990s, as HD-TV broadcasting commenced, HD-TV cameras suitable for news and general-purpose work were introduced. Though they delivered much better image quality, their overall operation was identical to their standard-definition predecessors. New methods of recording for cameras were introduced to supplant videotape, tapeless cameras. Ikegami and Avid introduced EditCam in 1996, based on interchangeable hard drives. Panasonic introduced P2 cameras. These recorded a DVC-PRO signal on interchangeable flash memory media. Several other data storage device recording systems were introduced, notably XDCAM from Sony. Sony also introduced SXS, a flash memory standard compliant to the Sony and SanDisk created express card standard. Eventually flash storage largely supplanted other forms of recording media. In 2000s, major manufacturers like Sony, Philips introduced the digital professional video cameras. These cameras used CCD sensors and recorded video digitally on flash storage. These were followed by digital HD TV cameras. As digital technology improved and also due to digital television transition, digital professional video cameras have become dominant in television studios, EFP and even in other areas since 2010s. Chronology 1926 to 1933 cameras were a type of flying spot scanner using mechanical disc. 1936 saw the arrival of Rca's iconoscope camera. 1946 Rca's Tk10 studio camera used a 3 inches I/O, image orthicon tube with a 4-lens turret. The Rca Tk30 was widely used as a field camera. A Tk30 is simply a Tk10 with a portable camera control unit. The 1948 Dumont Marconi Mk4 was an image orthicon camera. Marconi's first camera was shown in 1938. ME cameras from the UK were used in the US in the early 1960s, like the ME 203/4. Later in the 60s the ME 2000 and ME 2001. In 1950 the arrival of the Vidicon camera tube made smaller cameras possible. 1952 saw the first walkie-talkie portable cameras. Image orthicon tubes were still used till the arrival of the Plumicon. The Rca Tk40 is considered to be the first color television camera for broadcasts in 1953. Rca continued its lead in the high-end camera market till the Tk47, last of the high-end tube cameras from Rca. 1954 Rca's Tk11 studio camera used a 3 inches I/O, image orthicon tube with a 4-lens turret. The Rca Tk31 was widely used as a field camera. A Tk31 is simply a Tk11 with a portable camera control unit. There is some commonality between the Tk11/Tk31 and the earlier Tk10/Tk30. Ikegami introduced the first truly portable handheld TV camera in 1962. Philips' line of Norelco cameras were also very popular with models such as PC60, PC70 and PCP90. Philips BTS Broadcast Television Systems Incorporated later came out with an LDK line of camera, like its last high-end tube camera the LDK6. Philips invented the Plumicon pickup video camera tube in 1965, that gave tube cameras a cleaner picture. BTS introduced its first handheld frame transverse CCD charge-coupled device CCD camera the LDK90 in 1987. Bosch Verne marketed a line of high-end cameras in the US ending with the tube camera KCK40. Image Transform used specially modified 24-frame KCK40 for their image vision system. This had a 10 MHz bandwidth twice NTSC resolution. This was a custom pre-HD TV video system. At its peak the system was used to make Monty Python live at the Hollywood Bowl in 1982. This was the first major high-definition analog wideband videotape to film post-production using a film recorder for film out. In the 2000s, major manufacturers like Sony, Philips introduced the flash storage-based digital television cameras. Since the 2010s, these digital cameras have become most widely used of all other systems. Usage types: most professional cameras utilize an optical prism block directly behind the lens. This prism block separates the image into the three primary colors, red, green, and blue, directing each color into a separate charge-coupled device or active pixel sensor mounted to the face of each prism. Some high-end consumer cameras also do this, producing a higher resolution image, with better color fidelity than is normally possible with just a single video pickup. In both single sensor and triple sensor designs, the weak signal created by the sensors is amplified before being encoded into analog signals for use by the viewfinder and also encoded into digital signals for transmission and recording. The analog outputs were normally in the form of either a composite video signal, which combined the color and luminance information to a single output, or an RYBYY component video output through three separate connectors. The digital outputs are in form of a HDMI output. Studio cameras equals. Most television studio cameras stand on the floor, usually with pneumatic or hydraulic mechanisms called pedestals to adjust the height, and are usually on wheels. Any video camera when used along with other video cameras in a multiple camera setup is controlled by a device known as CCU, to which they are connected via a TRAX, fiber optic or the almost obsolete multi-core cable. The CCU along with Genlock and other equipment is installed in the production control room, often known as the gallery of the television studio. When used outside a formal television studio in outside broadcasting, they are often on tripods that may or may not have wheels. Initial models used analog technology, but are now obsolete, supplanted by digital models. Studio cameras are light and small enough to be taken off the pedestal and the lens changed to a smaller size to be used on a multiple camera setup's shoulder. Cameras can be mounted on a tripod, a dolly or a crane, thus making the cameras much more versatile than previous generations of studio cameras. These cameras have a tally light, a small signal lamp used that indicates, for the benefit of those being filmed as well as the camera operator, that the camera is live, that is, its signal is being used for the main program at that moment. N cameras equals. N video cameras were originally designed for use by news camera operators. While they have some similarities to the smaller consumer camcorder, they differ in several regards. N cameras are larger and heavier, and usually supported by a camera shoulder support or shoulder stock on the camera operator's shoulder, taking the weight off the hand, which is freed to operate the zoom lens control. The camera mounts on tripods with fluid heads and other supports with a quick-release plate. 3 CCDs or CMOS active pixel sensors are used, one for each of the primary colors. They have interchangeable lenses. The lens is focused manually and directly, without intermediate servo controls. However, the lens zoom and focus can be operated with remote controls with a television studio configuration operated by a camera control unit. A rotating behind the lens filter wheel, for selecting an 85A and neutral density filters. Controls that need quick access are on hard physical switches, all in the same general place on the camera, irrespective of the camera manufacturer, such as gain select, white-black balance, color bar select, and record start controls, and not in menu selection. All settings, white balance, focus, and iris can be manually adjusted, and automatics can be completely disabled. Professional BNC connectors for video out and Genlock in. Can operate in electronic viewfinder or external CRT viewfinder. At least 2 XLR input connectors for audio are included. Direct slot in for portable wireless microphones. Audio is adjusted manually, with easily accessed physical knobs. A complete time code section is available, allowing time presets. Multiple camera setups can be time code synchronized or jam synced to a master clock. Bars and tone are available in camera bars, a reference signal that simplifies calibration of monitors and setting levels when duplicating and transmitting the picture. Recording as to a professional medium like some variant of Betacam or DVC-PRO or direct-to-disc recording or flash memory. If as in the latter two, it's a data recording, much higher data rates are used than in consumer devices. EFP cameras Electronic field production cameras are similar to studio cameras in that they are used primarily in multiple camera switched configurations, but outside the studio environment, for concerts, sports and live news coverage of special events. These versatile cameras can be carried on the shoulder, or mounted on camera pedestals and cranes, with the large, very long focal length zoom lenses made for studio camera mounting. These cameras have no recording ability on their own, and transmit their signals back to the broadcast truck through a fiber optic, TRAX or the virtually obsolete multi-core cable. Others. Remote cameras are typically very small camera heads designed to be operated by remote control. Despite their small size, they are often capable of performance close to that of the larger ENG and EFP types. Block cameras are so called because the camera head is a small block, often smaller than the lens itself. Some block cameras are completely self-contained, while others only contain the sensor block and its preamps, thus requiring connection to a separate camera control unit in order to operate. All the functions of the camera can be controlled from a distance, and often there is a facility for controlling the lens focus and zoom as well. These cameras are mounted on pan and tilt heads, and may be placed in a stationary position, such as atop a pole or tower, in a corner of a broadcast booth, or behind a basketball hoop. They can also be placed on robotic dollies, at the end of camera booms and cranes, or flown in a cable-supported harness, as shown in the illustration. Lipstick cameras are so called because the lens and sensor block combined are similar in size and appearance to a lipstick container. These are either hard-mounted in a small location, such as a race car, or on the end of a boom pole. The sensor block and lens are separated from the rest of the camera electronics by a long thin multi-conductor cable. The camera settings are manipulated from this box, while the lens settings are normally set when the camera is mounted in place. See also. References. Notes Bibliography Zettel, H. 2006 Television Production Handbook, Thomson Woodsworth. ISBN 0-534-64727-8. External links, Television's history through the eyes of its cameras. Over 3,000 images and largest site of its kind worldwide. History of RCA cameras.